Simon White first observed the sky on a mountain telescope in Chile.
It was quite extraordinary because the sky seemed so bright, because in fact it was extremely dark. You really sort of feel how small we are, and you begin to feel there is some kind of connection between what we do and something which is much bigger out there.
Simon was born in Kent, but grew up in Cornwall, England.
My mother was a housekeeper, and I never knew my father. We were living in a very rural place. I was mostly interested in the flowers and the birds and walking around and learning stuff. The local county psychologist arranged for me to go to a boarding school in Sussex. I became interested in science and languages and mathematics, and also, for a while, I played the violin.
He won a scholarship to study applied maths at Cambridge University.
There's a natural consistency in mathematics which I enjoy. Mathematics is how you understand the wonders of space.
He obtained his master's in astrophysics in Toronto, but fascinated about a PhD in maths or astronomy back at Cambridge.
The applied maths department was in the basement in the center of town, in a rather unpleasant place. The Astronomy Institute was outside town in a new building, much pleasanter, so I decided to go into astrophysics. To study how structure in the universe develops in time, you have to understand whether your mathematical model really can describe the phenomena you see. And so computers came to take a major role in this.
He researched what constitutes dark matter that fills most of the universe.
I thought the way to do this was to try and understand how galaxies and galaxy clusters formed. I set up a calculation inside the computer, which was a spherical region in the uniform universe, which was expanding. And then as the calculation evolved, it became lumpier and lumpier, and all these lumps eventually fell back together to make a single cluster of galaxies. And what we learned from this is how inhomogeneous this structure formation process was.
His simulations were later proven by pictures from the Einstein X-ray Observatory.
This was, from my point of view, was lucky.
Simon was a postdoc, researcher and professor in Britain, the US and France. He and colleagues became the first to disprove an idea dark matter comprised of pure elementary particles called neutrinos.
We started looking at a family of particles called cold dark matter, which have different initial conditions coming out of the Big Bang than the neutrinos.
In many simulations published in the 1980s, they
eventually demonstrated relatively convincingly that many aspects of the real galaxy distribution could be understood from cold dark matter. It was still quite controversial because, after all, we were claiming that most of the matter in the universe is in the form of elementary particle that's never been seen in any accelerator and is not required.
Their simulations also revealed dark matter halos surrounding space objects.
We discovered all the dark matter halos, although they all form in different ways around different objects, they nevertheless all have a similar structure, and that you can describe this in a very simple way. Now it's called the Navarro-Frank-White profile.
In 2005, Simon and colleagues started a very large simulation known as Millennium.
To model the formation of the whole population of galaxies inside individual simulations of the dark matter distribution. It turned out the distribution of the galaxies inside the simulated universe was actually very close to the distribution of galaxies in the real universe.
He really can see very deeply into things. He has an incredible memory. He can really cite commas of some of his papers.
If you go to him and ask him questions, he has with 99% certainty always an answer. He's very smart, so a brilliant person.
Simon works still is the backbone of a lot of the things we're doing today. He's such a critical mind that he can formulate important questions even in fields that might not directly relate to his daily work.
If life develops naturally, then there could be present in many environments throughout the universe that look like the Earth. I study space because I'm interested to understand how our universe evolved, quite independent of the question of life.
In 1994, Simon moved to Munich and became a director at the Max Planck Institute.
I felt close to European culture, so I wanted to come back to Europe.
Simon's astrophysicist wife, Guinevere Kaufmann, is also a director here. He was her PhD supervisor at Cambridge. Guinevere's Shanghai-born mum had lived in Hong Kong. Her father is an American physicist. Guinevere did her postdoc at Berkeley.
But living transatlantic apart was difficult.
We went to Marrakesh.
You proposed in Marrakesh.
Proposed? Well, you also accepted.
Oh, yes. We got married in Cambridge. I think excellence and ultimate commitment, yeah, that's what Simon taught me.
It was admirable that she found her own scientific profile, which is clearly independent of mine. Oh, I like to go out and do other things and try and forget about the office, go home, have dinner, go out to a concert, go hiking.
When son Jonathan was born in 1996,
They installed a computer in our basement where I could log on here, and that was life-saving.
Jonathan is studying history and politics in university.
Dad was always very good at just saying, whatever you're passionate about, do that. He was around a lot, lots of fun. I got to go traveling with him a lot. What I picked up from my dad most was a love for reading and a natural curiosity about the world.
Simon speaks several European languages.
When I was an undergraduate, I spent about 2 or 3 summers actually traveling around Europe going to museums. I got particularly interested in Renaissance art from Holland and Belgium. It's important to be honest when you're doing science about what it does explain and in particular about what it does not explain. By now I have about 500 published papers. I have over 100,000 citations at this point. I stopped formally being a director in 2 years' time, but I don't expect to stop doing astronomy.